Okay, so on this video, I'm going to go over 3 examples of piecewise functions where you're using the 12 basic functions and just translations of those 12 basic functions. So the first one that I'll be doing is h of x is equal to 1 over x plus 3 when x is less than negative 3, and x plus 1 squared minus 3 when x is greater than or equal to negative 3. So at this point, you might want to pause, write down the equation, and then try to graph it on your own. Okay, so now let's take a look to see what this looks like. So what I would recommend is draw each of them first, and then get rid of the part that you don't want. So we're going to draw 1 over x plus 3. Now I know that 1 over x looks like this. Basically, this is 1 over x, the reciprocal function. But I want to move this and shift it over 3 units. So what I'm going to focus on is the vertical asymptote. Now I'm going to move this vertical asymptote to the left 3 units. So instead of that being there, it's going to have a vertical asymptote here. And look like this. Well, I only want this graph when x is less than negative 3, so I'm just going to go ahead and get rid of this part right away because I don't need that part. All I need is this part here. Then I'm going to have x plus 1 squared minus 3. Well, x plus 1 squared minus 3, that's a parabola. And if I take x squared, I'm going to shift this parabola over 1 unit and then down 3 units. So that's the vertex. So I'm going to have a graph that looks like this. And I want to stop at x equals negative 3. So if I plug in negative 3 in here, I'm going to get negative 3 plus 2, which is negative 2 squared, which is 4 minus 1, which is positive 1. So actually, yeah, that looks about right. This is going to be right here at this point right there. And that's it. That would be the graph. Okay, so let's move on to the second one. The next one we're going to look at is, just on a piece of paper here, f of x equals ln x plus 2 minus 3 when x is greater than negative 2, and e to the x plus 2 minus 2 when x is less than or equal to negative 2. So again, you might want to pause this, try it out, and then replay it to see if you got the correct graph. So we're going to start with ln of x plus 2 minus 3. Well, the ln graph, if you remember, the ln just looks like that. So I'm going to shift this over 2 units to the right, to the left, and 3 units down. I'm going to use the x. So 1, 2, and then down 1, 2, 3. There's the bell. I'm going to hurry up on this. And that's going to give me the graph that looks like this. And x greater than or negative 2, that's perfect. E to the x plus 2 minus 2, it's e to the x, which looks like this. And I'm going to shift that to the left 2 and minus 2. So I'm just going to take the y-intercept here and move it over to the left 2 and down 2 units here. Graph it like this. But I don't want values greater than negative 2, so I'm just going to erase this part and leave it right there, and that's the graph. Okay? Okay. And finally, the last one you could try out if you want square root of negative x, greatest integer, and negative x minus 3 squared plus 2. Negative x, square root of negative x is a reflection around the y-axis, so it looks like this. The greatest integer is actually going to be right there. It's an open circle, and we're going to stop right there at 2. And then this is a parabola that goes down, but it's shifted over 1, 2, 3, and up 2. So there's the vertex, and it actually goes down here and down like this. And it actually closes this because this is the same coordinate. If I plug 2 in here, I'm going to get 1. And that's the graph. Okay, so hopefully that helps. See you next time.